In this video, I just want to do a little more work with making series from series we already know. And all of these will be Maclaurin series and using kind of the series that we were to memorize. So if you recall, e to the x is generated by this. So e to the 3x, every time we see an x, we make it a 3x. So it's going to be 1 plus 3x plus. Now, here you're going to be a little careful because we're substituting an entire 3x in place of x. So it's 3x squared, so it's actually going to be 9x squared over 2 factorial. And the next term, of course, 3x cubed, it'll be 27x cubed over 3 factorial. And in the interest of time and space, I'm not going to reduce, I'm not going to figure these all out. Both of them would be 9/2, but I'm just going to go straight to the general term, which would be 3x to the n over n factorial. Now in this next one, you see that we're taking e to the x and we're multiplying it by x squared. Well, e to the x, remember this is kind of the leap we've talked about. We need to be able to think about the fact that e to the x is equivalent, or at least approximately the same, as this polynomial right here. So if I'm going to multiply e to the x by x squared, that's the same as multiplying every one of these terms by x squared. So x squared times 1 is x squared. X squared times x is x cubed. X squared times x squared over 2 factorial is x to the 4th. Over 2 factorial. X squared times x cubed over 3 factorial is x to the 5th over 3 factorial. So again, just notice I just multiplied every single term by x squared. So my general series is x to the n over n factorial multiplied by x squared, which I can reduce to be x to the n plus 2 over n factorial, like that. Finally, this bottom question, you see I'm actually doing two things. I'm putting 5x in place of x, and I'm multiplying by x. So you might want to do this in 2 spots, or 2 steps. You might want to say, okay, e to the 5x, that is 1 plus 5x plus, and just remember, most common mistake here is people forgetting to also square the numbers. So it's 5x squared, so it's 25x squared over 2 factorial. And it's going to be 5x cubed, so 125x cubed over 3 factorial. And then, if you're going to multiply by x, multiply this entire side by x as well. So we get x plus 5x squared plus 25x cubed over 2 factorial plus 125x to the 4th over 3 factorial. And my general term, we had 2 things happen. We put a 5x in place of x, and we multiplied by an additional x. And you could clean this up. You could say it's 5 to the n, it's x to the n plus 1, and it's n factorial. Okay. Now, I had 2 questions here. First of all, why can't we use this shortcut to find the Maclaurin series for e to the x plus 1? Now, I want you to think about this for just a second. Imagine, it's e to the x. Imagine for a second that we went up here and every place we had an x, we just made it x plus 1. 1 plus x plus 1 plus x plus 1 squared over 2 factorial plus x plus 1 cubed over 3 factorial and so on. So it would be x plus 1 to the n over n factorial. And you can do that. That is a substitution you can absolutely make. The problem with doing that, so imagine x plus 1 squared over 2 factorial, x plus 1 cubed over 3. The problem with doing that is it's no longer Maclaurin. Now it is a Taylor series about x equals -1. Okay, and I made the graph here, and I'm going to slide it in, see if we can see it. So you'll see here at -1, that's where we actually are perfect. It's so, I don't want to say this substitution doesn't work because it does work. but it doesn't make a new Maclaurin. And the reason is we have shifted the function 1 unit to the left, and then we shifted the series 1 unit to the left. So it's not that it doesn't work, but it isn't Maclaurin anymore. Now I wanted to do one more here. This series, we're going to use the geometric sum. Okay, so 1 over 1 minus x. Remember, this is 1 plus x squared plus x cubed, and so on. It is x to the n. It's the general series. So in this case, I want you to think about this is like x squared multiplied by 1 over 1 minus 3x. So we're doing two things. We're substituting a 3x in everywhere there was an x, and we're multiplying by x squared. So let's do this maybe in 2 steps. Okay, let's start by plugging 3x in. So 1 over 1 minus 3x. This can be approximated with 1 plus 3x plus, now remember it's 3x squared, so it's 9x squared plus 27x cubed. Okay, and now we're multiplying this by x squared, so we do that to the other side as well. So we've got x squared plus 3x cubed plus 9x to the 4th plus 27x to the 5th. So our general term, well, we had 3x to the n, and we multiplied by x squared. So we've got 3 to the n and x to the n plus 2.